In our final segment of this series, Dr. Ronald Schaefer, CEO of PhotoMachining, will discuss whether contract manufacturing or a system purchase is right for you. Go to PhotoMachining.com for the latest updates on our next educational video series. Over to you, Ron.
Thank you, Rick. So all the things we've talked about so far are interesting from a technology point of view. What lasers we use, what materials we can process, the feature sizes. But then the next question becomes, do you want to do this job in-house or do you want to do it at a contract manufacturer? Both can be valuable resources, and I want to talk a little bit about when the right time is to choose a contract manufacturer or to choose an in-house system. So let's talk about contract manufacturing, the positives. First of all, I have a question mark at the end of the first bullet point. The overall lower cost per part in volume can be lower. Is that true? Now, one would think that part of the reason you'd want to bring contract manufacturing in-house is so that you get a lower price. And sometimes that is true. However, you have to remember that a large manufacturer usually has a lot more overhead than a small manufacturer. So sometimes small manufacturers can even be more cost effective than bringing the parts in-house. So the first one could be an option in some cases, even though it seems counterintuitive. Secondly, it's ideal for prototype and small batch runs. You don't have to outlay the cash for a big laser system that's very expensive if you just want to do one and twosies or small batch runs. No capital expense. There may be a tooling expense if there's tooling that's required that's unique to the situation. There's no equipment to maintain in-house. There's no need for a trained operator or a laser engineer or an internal safety officer. And you get to work with people who hopefully know what they're doing with respect to lasers and laser manufacturing. So contract manufacturers can, number one, help find the right laser. In some cases, I still get phone calls from people who say, well, we want to talk about using lasers, but we're not very optimistic because we used lasers years ago and they didn't work. Well, lasers aren't just lasers. There are a lot of different kind of lasers. There are different wavelength lasers, there are different power lasers, there are different beam quality lasers, there are different pulse length lasers. So a contract manufacturer who has a wide variety of these lasers can actually help you identify which laser would be best for you in your situation. When do you use a CO2? When do you use a femtosecond? When do you use a picosecond? All these questions can be answered before a large investment is made on an in-house system. So some of the negatives of contract manufacturing. Again, more expensive per piece in high volume. One would think that would be cheaper to bring the contract manufacturing in-house using an in-house system. But in some cases, this may not actually be true. A definite negative of the contract manufacturing is that there's very little opportunity to retain proprietary knowledge. Most of the time, the contract manufacturer has done similar types of things before, and even if something is developed, it has to be very clear up front that the intellectual property is going to be retained by the customer. So usually the intellectual property is retained by the contract manufacturer. The delivery is affected by the job shop schedule. Contract manufacturers are working for a lot of other people, not just you as a customer. And so this has to be scheduled into the job shop load. Whereas if you bring the thing in-house, in principle, you have control over your own agenda. The quality control is dependent on the job shop's equipment and the abilities. In some cases, this is actually good because the job shop is set up to have a lot of good metrology. But there are also other cases where either the end customer has better metrology available, or B, there's something very specific about the metrology that can't be done in general with microscopes or SEM, but something very specific has to be built. And then the last thing is that it's difficult to change suppliers, especially, for instance, in the medical device industry. If you get FDA approval to use a contract manufacturer, it's going to take a lot of time and a lot of money to qualify a number of different vendors. So usually once this step is reached, it's difficult to change suppliers if that's what you want to do. So let's look at some costs for contract manufacturing. Typically there's some kind of recurring cost, such as a setup cost. This is usually done with each job or each setup, and the The value of this depends on the complexity of the setup, the cost of the laser, the cost of the laser system, maybe even how much the laser system is utilized. If it's utilized and booked up most of the time, it might be a little bit more expensive to get in line, as we say. The next thing, there may include some tooling and programming costs, which are non-recurring engineering. And that is true as long as the parts don't change. If the parts change, then new tooling and/or new programming may be required. And then we have piece pricing. The price per part is dictated by a lot of different things. It's dictated by the complexity, by the laser that's being used, by the number of parts per lot. If you're running 1 part per lot or 10,000 parts per lot, you're probably going to get a price break on the 10,000 as far as a piece price. It also has something to do with the handling and shipping requirements. If the handling and shipping requirements are somewhat burdensome, that will also affect the piece price. So a general statement, hourly rates in the laser contract manufacturing industry generally range from about $100 per hour on the less expensive side to about $500 per hour on the more expensive side. The less expensive side being things like marking. The high expensive side being things like high power USP lasers. And then also there may be costs associated with the actual shipping and handling of the parts. So all these things has to be considered when you're using a contract manufacturer. Now let's talk about in-house systems. Positives. Again, one would think you'd have a lower cost per part in volume. You have the possibility to retain control of the process, especially when the laser is the last step in a high-value part. You can integrate into a production line, which you couldn't do if you're sending parts out to a contract manufacturer. The shipping and the handling would hopefully be easier. Your quality control is internally controlled instead of externally controlled. In principle, it could be easier to ramp up. By that, I mean that if you get a system that's designed to work or that you think is going to work for 1 shift 5 days a week and something comes up, you can go to 2 shifts, you can go to 3 shifts before you get a new tool. So in principle, you can control a personnel ramp up if that's required. If you develop any applications technology in-house, that applications technology is yours, you own it. The contract manufacturer isn't going to own that. And I put a statement in there that lasers are less scary than they used to be. So right now, people don't even think of these laser tools as lasers. They think of them as a box that you press button and something happens. And that something is hopefully making parts for you that are very high quality at a very acceptable cost. The negatives of bringing a system in-house. First of all, there's a large capital expense. Secondly, you need an infrastructure. And most of the time, these lasers really like to work in a clean room type of environment, especially the micromachining lasers and lasers such as short wavelength and short pulse lasers. And if you are in a clean room space is expensive. So remember that. There's usually limited system flexibility. So for instance, a contract manufacturer will have his laser system set up so that he can address a number of different customers easily. One day he may be drilling catheters, the next day he may be making solar panels, and the next day he may be drilling holes in some kind of a filter device. Whereas usually when a customer buys a system, they have one particular part they want to make or a very limited subset of parts that are pretty near, if not identical, very close to each other in their configuration and the material that they use. So these systems are generally meant for high throughput, but they're not really high flexibility, especially if they have one laser in them, which is, for instance, a ultra short pulse laser, which is very good for micromachining, but wouldn't be any good for welding. Okay, next thing, it takes up valuable floor space, and the floor space gets more valuable when you talk about it being in a clean room. The next point, there are certain personnel that are needed. You need at least one operator, probably, if you're in a production environment anyway, and probably you'll need several operators. You need at least one engineer who can set up the jobs so that the operators can run them. And then within that company, you'll need a safety officer. And the need for a safety officer is somewhat dependent on which state you're in, but there are OSHA requirements, and generally a safety officer has to be named at a company. The safety officer in principle could be the engineer. Usually it's somebody different, but again, there at least has to be somebody tasked with making sure that the laser is operated safely. And then the final thing is that you really need an in-house owner. I've seen many situations where the managers will buy a laser system, and in some cases they buy a laser system to take over the jobs that employees are already doing. So they're taking a manual labor step away and costing jobs, if you will. In some cases, it's hard to find an internal employee who really wants to own this system because A, it may be taking their friends' jobs away, and B, they had no input into the specifications or anything. They're told at some point, you will run this system. So finding an internal owner for the system is very, very important if you're going to get the best utilization and the best bang for your buck. Now let's look at some typical system costs. The laser is usually the highest cost item on the system, and that especially is true for ultraviolet and ultra short pulse lasers. They also include the beam delivery components, the motion components, facilities like air, chiller, pneumatics, exhaust, and so on. It includes AC distribution, usually includes some sort of a vision system, and then finally software to run everything and a Class 1 enclosure for safety. It can also consist of delivery costs, shipping costs, warranty costs. Warranty is usually 1 year from the time of purchase. That's pretty standard. Some lasers have a 2-year warranty, although systems usually only have a 1-year warranty. There may be provisions for service and maintenance contracts. There may be provisions for training. There may be provisions for spare parts. So, all of these things considered, typical system costs vary very widely. You're probably looking at about $20,000 on the low end for a simple IR marker, and probably do a couple of $1 million on the high end for typically, let's say, a laser additive manufacturing tool that's pretty much state-of-the-art and high throughput. Typical micromachining system costs, though, are probably in the $200,000 to $600,000 range for a typical micromachining type system. All right, so again, like I said, the laser markers are generally cheaper, and especially if they don't have any kind of automation or part handling, or very simple automation and part handling. Those typically go in the range of around $20,000 to $70,000. An infrared laser manufacturing tool typically goes for around $200,000 to $400,000. And much of this depends on the cost of the laser, the size of the laser, the size of the envelope for the stage travel. A 6-inch travel is going to be a lot less expensive than, for instance, a 24-inch travel. They also include other things like facilities costs and everything else. So laser micromachining systems in the UV and the USP, they would be even more expensive, not only because the laser is more expensive, but the optics and some of the ancillary equipment becomes more expensive. Again, typically you're looking at $400,000 to $600,000 for your typical high-end UV or USP laser micromachining system. For laser additive manufacturing systems, it depends on whether you're using it for metals or plastics, and it also depends on whether you're looking for high throughput or not. You can get some in the range of, let's say for plastic additive manufacturing, in the range of a few $100,000. And if you want to look for metal additive manufacturing, you're probably looking in the range of $400,000 to $500,000 to start, and up to $1 million for a larger tool. Laser welders are somewhere in between the micromachining systems and the markers. They typically go for around $70,000 to $200,000, again depending on the size of the laser and the ancillary equipment that are involved. And one thing I'll note is that you generally get what you pay for. So if you look online, there are brand new systems that are listed on places like Alibaba.com where you can buy things very cheap, but the word is probably cheap. You have to be careful about what you get, especially in the case of high precision machining. So laser operating costs. The actual cost to operate a laser is dependent on things such as the electricity, how much electricity you use, how much cooling is required, how much do the gases cost, what are your other consumables like optics and so on, and what is your planned maintenance. If we look at, for instance, an excimer laser, it takes a lot of electricity, takes a lot of cooling. The gases are very expensive because you're using krypton or xenon and you're using a lot of neon, for instance. It uses a lot of consumables because the high UV pulse energy eats through optics fairly rapidly. And after 1 billion pulses or so, you have to get the reservoir refurbished. And that's a fairly high cost, on the order of tens to maybe hundreds of thousands of dollars. So excimer lasers, typically, if you take all of that into consideration, probably cost about $50 an hour to operate. And that's exclusive of capitalization, overhead, and labor. When you look at things like DPSS lasers, neodymium YAG lasers, and fiber lasers, you're probably in the $10 to $20 an hour range. And if you look at the ultra short pulse lasers, you're probably somewhere in the $30 to $40 per hour range. The picosecond and the femtosecond lasers don't have as much data as the eximers as far as longevity over tens of years, but I think this is probably a pretty good estimation. All right, so why would you use a contract manufacturer long term? Well, first of all, your volume may never be high enough to justify a capital expense of a couple $100,000. So in that case, it's a fairly easy decision. In some cases, though, the contract manufacturer actually has better analytical capabilities. In some cases, the piece price is already built into the product. I can think of several situations where the customer's volume is clearly enough to pay off a system within the first year or two, but the customer's a medical device manufacturer, not a component manufacturer, and if the piece price is okay and the quality is good and the delivery is good, they would rather just buy that product and build the piece price into their cost. And then, in some cases, the infrastructure to run lasers is just not in place. I like to tell everybody that we're just a machine shop, but we're a high-tech machine shop, so instead of using saw blades and drill bits, we use light. Well, that's all fine and everything, but you have to have the appropriate infrastructure in place to be able to use the light effectively, and not all real mechanical machine shops actually have that infrastructure in place. So sometimes, if you're looking at buying a laser, the cost to put the infrastructure in place is actually more than the purchase of the laser system itself. So you bring a laser tool in-house when, number one, your volumes get really high. And when you're looking at costs. So even if the direct laser costs are lower at a contract manufacturer, when you take into account the handling, the turnaround time, and everything else, it may increase the total costs such that bringing the laser tool in-house is actually a good economic decision. You have the ability to inspect the parts in-house right on the laser. The logistics may be expensive when you're trying to ship things back and forth, and you shouldn't have the expense when it's in-house. And hopefully your infrastructure is already in place, or at least a large part of your infrastructure is in place, so you don't have that expense when you're just thinking about bringing a simple laser tool in. All right, let's look at a few case studies and determine, where do they fit. First one I'd like to talk about is laser additive manufacturing, making body parts. This has actually been done in several cases in several hospitals, and we think that this is a very big growing area, so that within, probably 10 years to 20 years, every hospital is going to have one of these devices in their shop so that things can be made real time during surgery or just around the time of surgery. It's probably the most exciting field in laser manufacturing today. It's estimated that many different body parts will be made and manufactured with these techniques. As I said, some applications have already been successfully demonstrated, and this tool will definitely be needed on site. It's not something you could make a drawing, send it to a contract manufacturer, wait for 2 weeks, and then have your part to put in the body. So in this case, clearly you want to have something in-house. Another case study is welding. Marking, cutting, and drilling tend to be contract manufactured more than welding. One of the reasons for this is that welding tends to be somewhat more difficult. The other thing is that the welds are more difficult to inspect, whereas when you're cutting a hole or drilling something, you can measure something on a coordinated measuring system, and you can come pretty close to finding out exactly what the dimensions of that part are. But it's different when you're trying to inspect a weld that needs to be hermetically sealed. You may need special equipment to do that. And that equipment is usually found at the customer site, not at the contract manufacturer's site. And also, the production volumes of these welding things and the type of product has a very big influence. So in this case, again, a lot of the welding tends to be brought in-house because the price for the systems is less than, let's say, for instance, a high-precision micromachining system, and also the quality control is more easily controlled in-house rather than externally. Here's another example of something you probably don't want to have contract manufactured, and that's implants for prostate cancer. These radioactive implants are made by sticking a piece of radioactive material inside a tube and then welding a cap over the tube. Well, you probably don't want to send your contract manufacturer radioactive implants and ask them to go ahead and do the welding, let alone having the ability to look at the weld and make sure that it's correct. So again, this is a case where you probably don't want to contract manufacture this kind of thing out. So, some final thoughts. First of all, the drive to reduce manufacturing costs is being pushed in all industries, but especially in the medical device industry. There's increased medical and microelectronics contract manufacturing going to Asia, primarily to China. So basically, we must offset that in the US anyway. And how do we offset that? We offset that by being clever. We can't compete with them on a labor cost, but what we can do is set up our equipment so that we're much more clever about how we process things so that the throughput is faster and the cost per part is less. We have some increased consolidation of laser processing within the trusted contract manufacturers in the US. And what I'm saying there is that if you've been in business and if you've shown that you can make quality parts with on-time delivery and a good price, an acceptable price, then you're probably going to get more business by virtue of the fact that you're already doing good business. And right now we're using new or retrofit laser tools in-house for streamlining, for cost reduction, with more automation and fewer people. This is how we're going to keep some of the contract manufacturing here in the US rather than having it go overseas. So finally, I want to talk about fundamentals of laser micromachining. It's a book that I've written that explains the fundamentals of lasers, micromachining, and applications. This book was written basically as a very first order tutorial to help people understand not only laser micromachining, but also the cost associated with micromachining. And this should be good for product managers, for financial managers, for salespeople trying to learn about laser micromachining, and for technical people working in the laboratory. There's a cover of the book. It's available at CRC Press or on Amazon.com. You'll see the ISBN number in the barcode on the left-hand side. You can look up that ISBN number and it should take you right to the CRC or Amazon webpage. And I think it costs about $100 a copy. And I hope that you, if you do buy this book, that you find it interesting and worth the money that's spent. So, in conclusion, I hope that we've convinced you that lasers provide a valuable and unique capability for high precision processing of many different kinds of materials. However, lasers are only light bulbs and they don't do anything but shine light. You need other things to make them into work tools, and the other things you need are beam delivery, motion control, facilities, and very crucial, good operators. You also need other things like Class 1 safety. So systems integrators can provide custom in-house solutions for manufacturing problems that integrate all of these things together, and reputable contract manufacturers can provide valuable resources for prototyping, for R&D, for pilot production, and even for high volume manufacturing. And we want to thank you for hopefully enjoying this series that we've put together on laser processing. There will be more of these videos coming out over time that are probably more application specific. And thank you for tuning in.